Okay, I'm just going to jump on and go over all the trigonometric graphs. We'll start with the easy ones and then we'll work our way up. So this is the sine graph. The reason it cuts at 0, 180 and 360 is because if you were to type sine 0, sine 180 or sine 360 into your calculator, you're going to get 0 as your answer for the height, for the y value. If you were to type in sine 90, you'd get 1 as your answer. And if you were to type in sine 270, you would get -1 for your answer on the calculator. Now, it goes up to 1 and down to -1 if there's no number here, because if there's no number here, it means 1 sine x. If there was another number, that would change these, and we'll discuss that later. The cosine curve looks like this. Okay, so it's a little bit different. It starts up at 1, then goes down to -1 at 180 degrees, and then back up. So again, if you were to type in cos 90 or cos 270 on the calculator, you would get 0 as your answer. Cos 0 would be 1, cos 360 would give you 1 as your answer, and cos 180 would be -1. And again, if there's no number at the front, it's going to go up to 1 and down to -1. Now, cosine curves and sine curves are continuous, so it would just continue the same pattern after the 360, and before the 360, it would come down, or sorry, before the 0, it would come down here, and so on. Okay, moving on. So if you've got a number at the front, this is your amplitude. So if there's no number at the front, the amplitude's 1. If there's a number at the front, your amplitude will be whatever that number is. So that's a 4. So the amplitude for this graph is a 4, which just means the graph goes up to 4 and down to -4, unless it's been shifted. Sometimes graphs will be moved up and down. But if both numbers are the same, that'll be your amplitude. If the numbers are different, the best way to work out your amplitude is work out the height. So the height here is 8, because there's 4 from here to here, and 4 from here to here, so 8 in total. And half of the height would give you 4. So the amplitude is always half your height. So you need to know that if the numbers are ever different at the front and not the same. Okay? Because it's just sine x, one curve will finish at 360 degrees. Okay, here I've drawn 3 cos x. So the amplitude is 3, goes up to 3, goes down to -3. And it's a cosine curve, so it'll just look like a regular cosine curves. If it's just cos x, one curve will finish at 360 degrees. That is also equivalent to your period. So your period is 360 degrees if that's where one curve finishes. So if it's cos x or sine x, the period is 360 degrees. That will change if you've got a number in front of the x value. Moving on to cos 2x. The period will be different in this one. Because it's a cos 2x, one curve is going to finish at 180 degrees. I always remember if it says 2x, it means you can fit 2 curves in between 0 and 360. So one curve would finish at 180 degrees. So the period is 180 degrees. And a way to do that is just grab the 360 and divide it by this number here. And that will always tell you the period. The amplitude's 1, and that's why it's up to 1 and down to -1. If it was sine 2x, that means you get 2 sine curves in between 0 and 360. So the period is 180. One curve is going to finish after 180 degrees. So the period is 180 degrees. And the amplitude is 1, half the height. Okay, now on to this one. I don't know if you can read that. My handwriting's a little bit messy, but it says y equals 5 cos 3x. So 5 is your amplitude. That's half the height. Goes up to 5, down to -5. The cos 3x means you get 3 curves between 0 and 360. 1, 2, 3. Okay. So where does one graph finish? One graph finishes at 120 degrees. So that would be your period. And again, you mightn't have the graph there to check. So you can just do 360 divided by 3 to get your period if you're asked for that. And remember, you're not asked for your amplitude and period all the time. Just read the questions carefully. A lot of times they'll just draw you the graph and ask for the equation of the graph. Or they might give you the equation and ask you to draw the graph. Okay. There's ticks in this one just because I was discussing it with the class earlier on Tuesday, so I'll explain why I ticked and so on. Anyway, on this one, I did not give you the full curves up to 360 degrees. I've drawn two curves, but there would be another one to take us up to 360. So I was being a little bit cheeky with this one, making it a little bit more tricky. So if one curve finishes at 120 degrees, 120 fits into 363 times, so 3x would be in your equation for the graph, okay? The 6 is your amplitude, so I was just ticking the 6 to say that's correct because we've got the 6's on top and bottom. And it's a sine curve, okay? Right, this is when we start to shift them about. So if you're asked to draw y equals 4 sine x plus 1, it's really important that you draw 4 sine x first. This gets you most of the marks. There's only one mark for then moving your graph upwards. So most of the marks are for drawing your 4 sine x first, and then another mark for moving that up one position, okay? So you can see I've marked on the side the different numbers. So my blue graph, which is y equals 4 sine x, goes up to 4, down to -4, and it's in the shape of sine. And it was just sine x, so it'll finish at 360. And then just lift it all up one position. So I just lifted up each coordinate. So here, I lifted up the coordinate, so that will be a 1 it's starting at. And then the turning point, instead of turning at 4, it's going to turn at 5, a height of 5. And I lifted up this coordinate one position and this coordinate one position. So just draw your original graph and move the coordinates up one position and then sketch over, and that will be that graph shifted up one position. Make sure your graphs are curved. They're not supposed to look like jaggy lines. Okay, right, this one. If I ask you to draw y equals 3 cos 2x, take away 1, that just means move your graph down one position. So you can see I've drawn the brown graph first this time. So the brown graph is 3 cos 2x. So that's why I've got two graphs between 0 and 360. And the amplitude's 3, so I've got a 3 and a -3. But if I move that down one position, instead of starting at 3, it's going to start at 2. And instead of turning at -3, it'll turn at -4. And again, I just put every coordinate one position down. You can see where I've actually drawn the dots. And then I've just joined it up. Okay, and label them correctly at the side as well. That's what you'd be expected to do. You'd expect to label both graphs. And if you've got different colorings, that's helpful as well. Okay, now onto our phase angles. This is when we move the graphs left or right. If you ever move a sine curve or a cosine curve 90 degrees, they will look the same as each other. Okay, so if you moved a sine graph 90 degrees to the left, it would turn out just like a cosine curve. So they will always tell you if it's a sine or a cosine in the question. All right. If it's been moved sideways. If it's really obvious, they might not, but most of the time they will tell you if it's a sine curve or a cosine curve. Okay, on this one, before you're able to draw y equals 2 sine x plus 10 degrees, you have to draw y equals 2 sine x first. So you can see my brown graph is the y equals 2 sine x. It's up at 2, down at -2, and it cuts at 180 and finishes at 360. I've just not written those numbers on because I didn't really have much room, but make sure you do show as many numbers as you can when you're drawing your diagrams. Then, if there's a plus, it means move it left. If there's a minus, it means move it to the right. So it's the opposite to what you would think. So if it's a plus, move it left. If it's a minus, move it right. So I've moved my brown graph 10 degrees to the left. So it's now cutting at -10, 170, and 350. Normally you have to draw graphs between 0 and 360. So if that was the case, you would then rub that little bit off. But you'd also have to extend it up, which is what I did here. Extend it up to where the 360-degree line would be. Okay? So just remember to read the question carefully. If it says draw it between 0 and 360, you have to rub out any previous lines up to that point and extend it a little bit at the end as well. Okay, I just want to go over the amplitudes and periods of this. You can see all the answers down the right hand side, but let me explain where we're getting them from. So if it's ever sine x and cos x, the period is 360 degrees. Okay, the amplitude is always a number at the front, so that's super easy. You can see I've just written 5, 3, 4, 6 all the way down here. So the amplitudes are always just the number at the front. That's just a little bit harder if you've got the graph and you have to work it out if the numbers aren't the same. So if the numbers aren't the same, remember it's half the height if you're shown a graph. But if you've got the graph function given to you, then it's really easy, it's just a number at the front. Okay, if there's a 2x and it's a sine or cos graph, to find the period, you just do 360 divided by that number. So 360 divided by 2 gives us 180. 360 divided by 3 gives us 120, so the period would be 120 for this fourth one. Tan's different. Tan doesn't come up as much because it doesn't have an amplitude. It's not that it doesn't have an amplitude, but the amplitude cannot be measured, so they can't ask you for that. The period's 180 in a tan graph, and it's 90 degrees. If it's a 2x, you just do 180 divided by 2. If it was a tan 3x, you would just do 180 divided by 3, which is 60 degrees. If they ever put a number at the front of a tan, it's just there to confuse you. You don't need it. You still can't find the amplitude. Okay. On this one, the negative, it's still got the same amplitude because amplitude's just half the height, so it would still just be a positive 2 for the amplitude. The period would be 120 for this one because 3x, 360 divided by 3 is 120. So just remember the period for a sine and cosine is 360 normally, and for tan 180 degrees normally. But if there's a 2x or a 3x or a 4x, you have to divide by that number to find out the period. Right, two more graphs to show you, one more shift and then one with a negative. Okay, right, this is going to be a shift to the right by 30 degrees. Okay, so you would draw your sine graph first. So I've drawn 5 sine x, up at 5, down at negative 5, and then I've shifted everything over 30 degrees. So I actually finished at 390. But often you'll be asked to only draw between 0 and 360. So if you are, you would rub that bit out and extend this line down to the y-axis, which I've done. Okay, right, going on to the negative one. Negative graphs mean the y values are negative if they were positive, and if they were negative, they'll go to positive. So you basically flip your graph upside down. So if you look at the brown graph there, it looks like a cosine graph but turned upside down, doesn't it? So I drew y equals negative 3 cos x first, and then I've moved it 40 degrees to the right. Okay, so if it ever says a minus at the front, just get your regular. So a regular cosine graph would look like that, and then just flip it upside down. Okay, so that's my cosine curve. And then I'm just going to move it 40 degrees along. So 40 degrees added on to 90, I get 130. And 40 degrees added on to 270, I get 310. And then I've just extended a little bit to where I think the 360 mark would be. And at the start, so a cosine curve would start high, but if you were to draw further back, remember, because they're continuous, it would go like that. So I'm just tilting it back a little bit towards the y-axis, since you normally have to draw between 0 and 360. Okay, hopefully that helps.